Hi. So in this chapter we're gonna learn about the transfer of thermal energy by conduction, convection and radiation. My name is Shahroz and I'm an online physics tutor, and I'm gonna take you through all the chapters of IGCSE Physics in this series of lectures. So do watch this video till the end so you could understand all the concepts of this chapter, and that will help you in solving the past papers, because after completing these all chapters I'm gonna switch on to the past papers and we're gonna see the solutions of the exam related questions. Alright, so for the transfer of thermal energy, the first thing that we have to discuss in this chapter, we're going to discuss about the conduction, convection and radiation, how the heat is transferred through the conduction, convection and radiation. But before that we have to discuss um, the properties of a good conductor and a bad conductor. So good conductor and a bad conductor. So good conductors are the ones that allow the heat to pass through them, that allow the heat and electricity to pass through them. And bad conductors are the ones that do not allow the heat and electricity to pass through them. So that's the simplest definition of the good conductor and a bad conductor. So I'll just write it here. The objects that allow the heat and electricity to pass through them, they are the good conductors. And bad conductors are the objects that do not allow the heat and electricity to pass through them. The objects that do not allow, or we can say they partially allow the heat and electricity to pass through them. The heat and electricity to pass through them. So normally the conductors and non-conductors are considered to be as solids, and the heat transferred through the solids is called conduction. So after this definition of the good and bad conductors, let me just give you some examples. So the example of a good conductor can be a metallic rod, it could be a wire, it could be a cooking utensil, etc. So these are the objects that are considered to be as the good conductor, that allow the heat and electricity to pass through them. Now for the bad conductor, I can consider the example of a plastic rod, a wooden object, okay, or some thermopore sheet. So they will be considered as the bad conductors. They do not let the heat or heat or electricity to pass through them. So after discussing the good conductor and the bad conductor, we have to see the process of conduction through which the heat is passed through the solids. So let me just erase it. Alright, so conduction. In this chapter we are basically discussing the transfer of thermal energy, how thermal energy is transferred from one object to another, or within one object from one point to another. So our objects under consideration would be solids, liquids and vacuum or gases. So first of all, let's see the conduction. So conduction is basically, it is the process by which heat is transferred through solids. process by which heat is transferred through solids is called conduction. For example, we have this metallic rod. On one end of this metallic rod, we have put a burner with a flame. So this burner is heating up this rod, and within this rod we have free moving electrons. So what happens is, when one end of the rod is heated, after some time the heat is transferred from the hotter end to the cooler end. So this is the cooler end, this is the hotter end, and the heat will be transferred from the hotter end to the cooler end. And why does this happen? Look, when we heat this end, the kinetic energy of this basically the electrons absorb that heat, and due to the absorption of that heat, the kinetic energy of these electrons increases, the electrons on this side. So when the kinetic energy of these electrons increase, they move with a faster speed. So when they move with a faster speed, they transfer the kinetic energy to the neighboring electrons. And when the neighboring electrons absorb the kinetic energy, their temperature also increases, and this process goes on until the heat is transferred all the way to the other end. So this process is called conduction through solids, and this is how conduction happens, and heat is transferred from one end to another. Okay, so I'll just write in short over here. The electrons on the left absorb the heat, their kinetic energy increases, and they move with higher speed. So when they move with a higher speed, they transfer their kinetic energy to other electrons, kinetic energy to neighboring electrons, so ultimately, so in the end, the temperature increases on the other end. So this is how conduction happens, and energy is transferred from one end to another. Okay, so now after the conduction, we'll discuss about convection. So let me just erase it. Alright, so convection. Let me just write down the definition first. So basically, the transfer of heat, through liquids is called convection. So when heat is transferred through the liquids, that process is called convection. Now, how the heat is transferred through the liquid, we have to discuss that phenomenon over here. So for that purpose, let's suppose this is a cylinder in which we put some water and put a burner at the bottom of the cylinder with a flame. So this is basically the burner that is heating up the water. So water is up till this level. Okay, so let me just mark the water with the blue color. So this is all water inside the cylinder that is being heated. Let me just mark it. This is water. Okay, Now in this water, the temperature over here is low, temperature at the bottom is high. And why is that? Because the bottom is close to the burner, so the burner is heating up the bottom, and the molecules are absorbing the heat. So when the molecules of the water absorb the heat, their kinetic energy increases, and when their kinetic energy increases, their temperature increases. Now an interesting thing happens here. When the temperature in this area increases, then this water becomes less dense. Hot water is less dense, so this water becomes less dense, and the water over here in this area, it's more dense. So as we know that the less dense objects, they rise up, and the more dense object, they sink into the water. So what happens is this hot water shifts upwards, and this space is occupied by the more dense water. So in this way, we'll have hot water at the top, and that hot water is replaced by the cold water that was previously at the top. So in this way, convection happens. So the less dense water goes on the top with higher temperature, and the water with the lower temperature at the top replaces that hot water at the bottom. So this process keeps on going, and this happens as a result of convection. So ultimately, after some time, the temperature of the water in the whole cylinder becomes constant, and this process is called convection. So if you have any question about this particular concept, you can just write down in the comment section, and I'll explain it further. But this is very simple. I'll repeat. When water becomes hot, or any liquid becomes hot, it becomes less dense, and the water at the bottom is less dense, and the water at the top is more dense because it has lower temperature. So the water with more temperature will go up, and the water with less temperature will come down due to its more density. And then when that water heats up, that water will go up, and the more dense water will come down. So when this process repeats itself again and again, then there comes a time when the temperature of the whole liquid will become same. So this process is called convection, and this is how the heat energy is transferred in liquids. So now convection is done. After the convection, we have to discuss the process of radiation. So let me just erase it. Alright, so radiation. So radiation is basically, it is the process by which heat is transferred from one point to another without any medium. In conduction, we had discussed that heat is transferred through the solid. In convection, we had discussed that heat is transferred through the liquids. But in radiation, heat is transferred from one point to another without any medium. So in radiation, the heat is transferred through the electromagnetic waves, and those electromagnetic waves could be microwaves, infrared waves, gamma rays, it could be any wave. Alright, so let me just write down the definition. The transfer of heat from one point to another without any medium is called radiation. So when heat is transferred from one point to another without any medium, it's radiation. So the best example for the radiation is the transfer of heat from the sun to the earth. So this is our earth, and this is the sun, and there is vacuum between the earth and the sun. So heat is transferred in the form of electromagnetic waves from sun to the earth. Okay, So in order to describe the process of radiation, we have to discuss the electromagnetic waves. So whenever electromagnetic waves are emitted or absorbed, we can say that the heat is transferred to and from that object. So I'll write it here. So radiation happens when the electromagnetic waves are absorbed or emitted. And the electromagnetic waves are absorbed or emitted. So in this example, the electromagnetic waves, like for this particular example, infrared waves, because for the heat we mostly consider the infrared waves, because whenever some things heat up or whenever there is some transfer of heat without any medium, it is usually in the form of infrared waves. So in this case we can say that the electromagnetic waves are being emitted from the sun and they are absorbed by the earth. So that emission and absorption phenomenon tells us about the radiation that the electromagnetic waves have done. So this is it that you have to understand about the radiation. Now there are some certain objects that are good absorbers of those electromagnetic waves, and there are some certain objects who are not good absorbers or emitters of those electromagnetic waves. So in order to discuss that, let me erase it. Okay, so good absorbers and emitters of electromagnetic waves. And on the other hand, we will discuss the bad absorbers and emitters of electromagnetic waves. So first of all, the good absorbers. So the objects with a dark color like black, gray, brown, they are good absorbers of the electromagnetic waves. So basically they absorb the heat faster, they become more hot quickly, and they also emit more heat. So for example, this is the sun and we have two cars. This car is of let's suppose black color, and we have another car, this one. So let's suppose this one is of blue color. So between these two cars, this black car has a darker color. So the electromagnetic waves from the sun, they will be absorbed more by this black car, and the inside temperature of that black car will be more as compared to that blue car. Okay, so in this way we can say that the dark objects are good absorbers of heat, and they are also good emitters of the heat. So basically if you have to emit the heat from certain object, you have to paint the outside of that object in black color. So for example, we are having a stove. So on the stove we put a black metal at the top. This is black metal and this one is the stove. We use the black metal because black metal is a good emitter of heat. So it's easy for the black metal to emit as much as possible the heat as it can. So for this one we can say that the dark objects are good absorbers and emitters of heat. On the other hand, let's talk about the bad emitters and bad absorbers. So the shiny polished objects or the white colored objects, silver colored objects, they are bad absorbers and bad emitters of heat. So if we have a shiny colored, or if we are wearing a white shirt and black shirt, so we'll feel more hot in the black shirt as compared to the white shirt, because the shiny objects, they are good reflectors of heat, they're bad absorbers of heat. So whatever heat they receive, they will just reflect it, and the inside temperature of that shiny object will be less. So bad absorbers, white objects, white or shiny objects are poor absorbers and emitters of heat. So whenever we have a shiny object, let's suppose we have a shiny object like this, the heat is coming from the sun. This is a shiny object. So what happens is the electromagnetic waves or the infrared waves, they will strike the object, because it's a shiny object, so it will reflect them in different direction. So when it reflects them in different direction, the inside temperature of the object will remain less. In this way, we can say they are good for reflection purposes. So if we want some object to remain cool, we use the outer surface of that object as shiny, so they could reflect as much heat as possible, so the inside temperature of the object remain less. Okay, so this is how we can describe the good absorbers and the bad absorbers. Now we have to discuss the transfer of heat to and from the buildings. So let me just erase it. Alright, so transfer of thermal energy or transfer of heat to and from the buildings. So let's suppose we have a tall building with several floors in it. 1, 2, 3, 4. These are the windows. Alright, so this is the sun that is emitting the heat in the form of electromagnetic waves that are being thrown onto this building. So what happens is, the structure of this building is probably made up of cement. So it's a solid. So the temperature of the molecules in the solid increases by absorbing the heat from the sun, and their kinetic energy increases. That kinetic energy passes through the other solids, and it is not a good conductor, by the way. It's a partially good conductor. So the electrons transfer the kinetic energy to their neighboring electrons, and in this way the structure of the building will become hot. So when the structure of the building become hot, the inside environment, the inside air will become hot due to the process of convection. So in this way, the heat will transfer into the building. Now at the night time, because there will be no sun, so then the heat that is trapped inside the building, that will leave the building, and the building will become cool again. So this is the normal process of transfer of heat to and from the building. Now if the color of the building is black, then it will absorb more heat. Okay, so it will absorb more heat, and as a result of that, the temperature will become high. If the color of this building is white, then it will absorb less heat, and as a result of that, the temperature of the building will be less. Okay, so it's preferable to use, if we do not want more heat to come inside the building. So let's suppose if the building is is in an area which has hot climate, like in the Middle East. So it is preferred to use the outside color of the building should be a shiny color, should be silver or white or any bright color. And if the building is in some region where the temperature is usually less, then it is preferred to use dark colors. So because the dark color could absorb more heat, so the inside of the building will remain hot. Okay, so this is how the heat is transferred to and from the building. Now, in order to protect the building from that transfer of heat, we can use different type of insulation, and within the insulation we can use the thermopore sheets inside the walls of the building. So insulation, so I'll write it here. Insulation is used in the building and the buildings to protect them from the transfer of heat. So when the insulations are used in the windows and in the walls of the building, then there will be less heat that will be able to transfer from the outside to the inside of the building. So the types of insulation that we can use, there could be the thermopore sheet. Thermopore sheets in between the walls of the building, and we can also use double glazed glass in the windows of the building. So with the help of the double glazed glass, there is a vacuum between, there are two glasses that are placed with each other, but in between those two glasses there is air. So air is basically the best insulator. So air is trapped inside those two glasses that do not allow the heat to come inside the building. So that's why we use double glazed glass in the windows, so in order to protect them from the heat that comes from outside. So these are the techniques that we can use to insulate the building, and in this way the less heat will be transferred from the outside environment to the inside. And also less heat will be able to move inside the building to the outside environment. So this is preferable in both hot and cold regions, so that we can able to manage the temperature according to our needs. Alright, so this is done for the transfer of thermal energy. So if you have any question, you can just write in the comment section, and do watch my videos, like complete videos. Do watch complete videos, because when we're going to do the past papers, we have to use these concepts in order to answer those questions, and I'm covering all the topics, all the points that are being mentioned by the Cambridge specifications. So I suggest you guys to watch all the videos till the end and ask if you have any question, and write it in the bottom in the comment section. So just write down the time at which you are having trouble in the comment section, then I'll try to answer all of your queries and all of your questions. Thank you.